Good morning, children. Today's thought: life is a collection of changes. So don't avoid changes. Take every change as a challenge. Some give success and some act as a stepping stone to success. What this means is change is the main factor of a happy and successful life. Only those people can attain success and happiness in life those who learn to manage changes. Changes are not always bad for us, and sometimes they come with new opportunities. So, we should always take the change as a challenge and move ahead in life. With this thought, let's get started with the third chapter in science: properties of natural resources. Let's recall. Which are the gases present in air? Children, try to recall. Last year, in your very first chapter on natural resources, you had studied about air. Layers of atmosphere. Now, what is this air? The air in the atmosphere around the earth contains nitrogen, oxygen, carbon dioxide, 6 inert gases, nitrogen dioxide, sulfur dioxide, water vapor, and dust particles. So you can see that air is a mixture of several gases and it is the chief constituent of the Earth's atmosphere. Besides these gases, air also contains water vapor and dust particles. The amount of the gases in the air is the greatest near the surface and decreases as we go higher and higher from the surface. That is, air becomes rarer at higher altitudes. Next question: why is air called a homogeneous mixture? Air is called a homogeneous mixture because the constituent gases which are present in the air, they cannot be separated naturally from the mixture, and therefore air is called a homogeneous mixture. Next question: what are the uses of the various gases in air? Children, if you remember, last year you have studied the uses of gases in the air. So let us recall it now. The highest percentage of the gas present in air is nitrogen. How much percentage do you remember? Right, 78. So nitrogen helps living things to build the necessary proteins. It is useful in the production of ammonia and in airtight packaging of foodstuffs. The next gas, which is 21%, is, do you remember? Right, oxygen. Oxygen is necessary for respiration in living things and for combustion. The next gas is carbon dioxide. It is present as 0.03%. And plants use carbon dioxide for producing their food. And carbon dioxide is used in fire extinguishers. Then argon, which is 0.9%, it is used in electric bulbs. Helium, it is used for obtaining low temperature and also for generating lift in airships. These are all inert gases now. Neon, it is used in decorative lights and for street lighting. Krypton, it is used in fluorescent tubes. And xenon is used in flash photography. So these are some of the uses of gases which are present in the air. Now you have an activity to be done wherein you have to tie two rubber balloons of the same size at the two ends of the stick. See to it that the stick remains horizontal. Now you have to remove one balloon and inflate it and tie it again to the original position. And now what you have to do is observe whether the stick remains horizontal. What you observe is the end where inflated balloon is attached, the stick goes down on the side of the inflated balloon. This means that air has weight. Only then the stick will go down. And we know that air is a mixture of gases. So, like all the other matter, air has mass and it has weight. Since it is bending one end of the stick, so it has weight. And since when we put air in the balloon expands in size. That means it is occupying space. So air has mass and it has weight. The next activity that you have is you have to take an injection syringe without the needle, pull its piston and observe it as you do so. What you observe is the piston can be pulled out easily, and when you pull the piston, it remains in that position even if you let it go. Now, close the inlet hole of the syringe slightly with your thumb. Pull the piston and let it go. Now observe. Is the force required to pull out the piston more or less than before? Of course, it is a little more. Does the piston remain as it is after you let it go? No. The piston tries to go back. So what happens over here is the molecules of the gases in the air are in constant motion. When these molecules strike a body, they create a pressure on that body. So this is the pressure of air that we call as atmospheric pressure. On pulling the piston with the inlet hole of the syringe closed, more space becomes available to the air in the syringe and it becomes rarefied. That means little amount of air is spread in more area. As a result, the pressure of the air in the syringe is lowered. Comparatively, the pressure of the outside air is very high. That is why when the pulled out piston is released, it is immediately pushed. And if this experiment is repeated, holding the syringe in different positions like vertical, horizontal or inclined, the position is found to go into the same extent in all the cases. So, from this what we can infer is that atmospheric pressure is same in all the directions. Find out, is there any atmospheric pressure on the moon? So children, take this as a homework and try to find out if there is any atmospheric pressure on the moon. And let us see this activity a little fun. Place a piece of cardboard on the mouth of a glass filled completely with water. Holding the cardboard firmly in place with one hand, invert the glass quickly. Take your hand away from the cardboard. What do you see? So for homework, today you have got two activities to do. The above question and this activity. This is an interesting activity. If you have a piece of cardboard or a card, just place it on a completely filled glass with water and immediately invert the glass, remove your hand and observe what happens. Thank you.